Welcome once again to the lecture series on transistor. So in this particular lecture, we are going to explore how common base mode transistor can be used as an amplifier. So let us have a look at the common base configuration. In our previous lectures, we have discussed this, and here it is shown that for NPN and PNP transistor, how transistor can be used in a circuit with the proper biasing. So now in our previous lecture we have seen that the base emitter junction JE is in the forward bias, whereas the collector base junction JC works in the reverse bias. So if we see the input characteristics of the transistor under common base mode, so we have seen that IE as the input current and VEB as the input voltage, keeping the output voltage VCB constant. So let us consider any value, say 5 volt. So here it is constant, and if we try to have a look at the resistance at this point, so we can see that for a very small change in the voltage there will be huge change in the current. So the input resistance Ri, which is VEB, that is the input voltage by input current, so this value is very small, very low for transistor in common base mode. Similarly, if we have a look at the output characteristics, so there we have seen this kind of output. So our output current was taken as IC and output voltage as VCB with input current IE constant. So let us consider some value, say 10 milliampere. So for 10 milliampere we are having this kind of output. So here also if we take the slope, so we find that for quite large change of VCB, IC is changing very less. So as a result of that, the output resistance R0 we are giving as output voltage by output current, keeping input current constant. So in this case also similarly the output voltage VCB constant. Okay, so R0, you can see that for a large change in VCB, very small change in IC. So as a result of that, this value of the output resistance is very high. So in terms of some hundreds of kilo ohms, we can have this R0 at the output resistance. So this is a typical condition for the amplification. Earlier we have seen the current amplification factor alpha, which is always less than 1. So that means there is no current amplification. So what is amplified here? It is the voltage. So common base amplifier or CB amplifier works as a voltage amplifier. So let us have a further close look. Let us consider the circuit. So this is our transistor. So let us consider any type, say PNP type transistor we are considering here, and this is our input voltage. I'm not showing the biasing here. Biasing is there. Without biasing it will not work, but since we are interested here in the AC response, so I'm just showing the AC input voltage. Okay, so do not confuse that there is no biasing. Biasing is there. I'm just not shown it. So let us consider some typical input voltage, and this circuit is being used with some amplification purpose. Say in IoT you can use the amplifier. So say from some sensor very low voltage is coming out, say maybe say 200 volt millivolt we are considering, and the input resistance is considered as very low. So let us consider, say this is 20 ohms. So keep the calculation simple. I am taking such values. Try to understand this concept only. So this is my input current. Similarly, this is our load resistance. So load resistance, let us consider a typical load, say 5 kilo ohms, and here we are taking the load voltage or output voltage VL. So here we have the output resistance R naught, and R naught we have seen it is typically quite high R naught. So R naught, let us consider say 100 kilo ohms. So when we consider this R naught and RL, we find that they are in parallel. So that will be parallel equivalent resistance will be equivalent to this lower resistance, since R naught is quite high. So output will be appearing across RL is the current into RL. So VL is IL into RL, and here the input resistance we can find, we can have that input resistance 20 ohms and input voltage as VI 200 millivolts. So the input current II is voltage by resistance. So it is coming say around 10 milliampere. So input current is 10 milliampere, and typically we know alpha value is less than 1. So let us consider say 0.99, 0.9 to 0.99, anything we can consider. So we get IL, that is equal to alpha into II, that is for typical CB configuration that we have seen, considering that ICBO nil, that is ignoring that ICBO part. So you can now multiply this value 0.99 into 10 milliampere. So it will be same, more or less same. Exact calculation, you can pause the video and have that exact calculation. So I am just for simplicity I am writing it. It is equivalent to 10 milliampere. It may come around 9.9 milliampere, but it's okay. We are just for understanding, we are writing it, keeping the calculation simple. Now this is my IL. So what will be my load voltage then? VL equal to IL into RL. So IL say 10 milliampere we have considered, RL is 5 kilo ohms. So this is 10 to the power 3, 10 kilo ohms, and this is milliampere. So here also we have 10 to the power minus 3. So this will get cancelled. So we get 50 volt. So output voltage is 50 volt, input voltage is 200 millivolts. So what is the amplification? A suffix V, this is the voltage amplification. A suffix V, this is voltage amplification factor, and for this case we are getting VL divided by VI. So that is 50 volt we have got, and VI is 200 millivolt, 200 into 10 to the power minus 3. So that is coming around 250 times. So input voltage is amplified 250 times. So typically AV is ranging from 50 to 300. So that is the typical range of AV for uh, common base amplifier. Now one may ask that uh, what is the reason for this conversion from 200 millivolt to 50 volt. So from where we are getting? We are getting this basically from the biasing voltage. These biasing voltages are helping to boost this input voltage. And another reason that we have discussed, it is from this input section is a low resistance circuit. Low resistance circuit, and we are transferring the current from the low resistance circuit to high resistance circuit. So because this is transferred from a low resistance circuit to a high resistance circuit, that is the main reason for the voltage amplification. If you can remember, in our first lecture we have seen that transistor meaning is transfer resistor. So here we are transferring the current from a low resistance circuit to a high resistance circuit. That is the typical reason for this voltage amplification. However, for CB mode we are not getting any current gain. So current gain alpha is less than 1. So that is how transistor works as an amplifier, by transferring the current from a low resistance circuit to a high resistance circuit, and overall CB amplifier works as a voltage amplifier. So I hope you could now visualize that how transistor amplifying action is taking place under CB configuration. So in our next lecture, we'll start our discussion on the CE mode, CE configuration, and there we'll have a look how CE configuration transistor works as an amplifier. Thank you very much.